Welcome, my name is Chaitanya. They call me Chai. I lead products for Google for catalog, data integration, data sharing. I'm going to be joined with Lou Yang, who heads Knowledge Catalog in my team. And we're going to talk about Knowledge Catalog. First of all, I want to set the record straight. Knowledge Catalog is not a new product. It's Dataplex for people who know the product. I think we have a lot of familiar faces who have been using Dataplex. We have rebranded it, but I think there is a lot of things that we have done from last year. So when we came into last year, some of the folks that I've seen over here spoke to us, and there were a lot of concerns they expressed that, hey, you know what, catalog should be doing this. So I think we took it to the next level, and I think what I'm going to talk about today is how do we evolve this catalog to become the context backend to actually power your intelligent enterprise. So we'll be joined with Bloomberg. Thanks to Bloomberg folks over here. I think they will be joined with Katherine and Hann. We're going to talk about their use cases and how they are using the Knowledge Catalog today, right? We know that the future of data, future of AI depends on data. And future of data is also intertwined with AI. And what is happening is every single industry is getting disrupted as we speak. The way you talk to your data, the way you ask questions, the way you find insights, it's constantly changing, right? And I think what customers are wanting, everybody wants insights faster than ever. The traditional way of, building a warehouse, building a data mart, building your reports, BI dashboards is all kind of diminishing, right? It's going away. And what business wants today is they want insights at their fingertips. And I think if you look at every single industry, every single domain, whether it is e-commerce, retail, telco, every single industry is getting changed because of how you interact with the data. Now, when we start thinking about it, we know that data is complex. Data comes in all shapes and sizes. It's multimodal, it's unstructured data, it's structured data from your operational databases, it can come from warehouses. So all these data, you need to start making sense out of this data. So when you actually are thinking about talk to your data and you ask a question, hey, I want to do a churn analysis on my customers from the last quarter. This talk to your data, it should be able to know what is a customer, what is a quarter, what does churn analysis mean? So a lot of this business semantics and all that stuff is not in these data platforms. It's completely, sitting outside. I know I see, some of our friends from Levi's over here who presented on this last year, and they have been doing this for the longest time. So what is happening is that when you ask these questions, where do you get the context from? What does this context mean? What does this semantics mean? So what we have done is, raw data, we know that it doesn't have any context. If you go to the underlying database, if you go into the underlying lakehouse or warehouse, you don't have any context at all, right? So there is obviously a gap. The other thing that you also have to understand is whenever you go to these underlying systems, you have to know, can I trust this data? I was actually talking to Noel Johanna from Forrester today, and one of the things that he said was interesting is every organization that he has met, at least 30% of the data has copies. 30% of the data is copied. And there are some enterprises which the data is copied over 80% of the data is actually have copies. So when you actually look at this data, there is a trust gap. How does AI or your agents that you are building on a daily basis can interact with this data when there is a trust gap, right? And then what happens is then obviously the human in the loop comes into play. The humans are spending 80% of the time sifting through this data, ensuring that this data is consumable, is ready, and you are not hallucinating with the agents with this data. And in the new agentic world, this is not scalable. The human way of curating the data and making it trustworthy and creating this context is not scalable at all, right? So and context, think of context as your map for the entire enterprise. So the way I actually describe it, and I think I've spoken to a bunch of you, is you take Waymo. In 2009, when it launched, everybody thought that, hey, autonomous vehicles don't exist. But when you look at Waymo is an intelligent, car that can go from point A to point B. But it doesn't know where is point A and point B, right? It needs Google Maps to power it to say that, hey, this is your source and this is your destination. And if you think about your enterprise data as this complex, map of roads, and the agents need that map to go from point A to point B. And that is your context map. So context is not stored anywhere. Context has to be evolved, and context has to be gathered by the systems. And it is not written anywhere. It is actually, split across multiple systems, and and it comes from various different signals. So when you actually look at and say, what is context? Why are we talking about context right now? Context is a lot of things, and these are only few signals, right? First is there is technical metadata. So catalogs have always existed. You always harvest, technical metadata from these systems, and then these are column names, table names, and so on and so forth, right? And there is operational metadata. Who is using the data? What is the lineage? What are the profiling statistics? All that stuff. There is trust metadata, which actually tells you, can I trust this system? Is this data actually trustworthy so that I can actually incorporate it in my context? Then there is semantic metadata. This is one of the most complex things that a lot of people are struggling to solve. Your semantics are in different places. They can be in your BI dashboards. They can be in most of the semantics are in tribal knowledge, by the way. A lot of people don't know what's the meaning of it. They'll go and ask a person within the organization. Or they can be in a semantic model. There is no one semantic model that rules them all, so you have multiple semantic models. So there is semantic metadata. And then there is also your relationships. How is data related? Now, when we talk about data, we are not talking about only structured data relations, right? We are also talking about unstructured data. How is it related to structured data? So if you have invoice PDFs that are in your GCS bucket, how is it related to my customer data, which is in Salesforce, and the order management data that I have in my custom applications running on Oracle, right? And then finally, there is agent guidance readmes. Now what these agents need is, you want to be able to supply readmes so that you actually say established context and relationships between this complex data estate. So all these things combine and make it into context. And this is not just, and context there'll be other signals that you want to gather. Each enterprise is very different. I only gave you a few examples, right? And then if you take this context, and what does universal context mean is there are three distinct things. It's layered, basically. So there is technical metadata, which is actually sits at the bottom. So all the catalogs have done it, catalogs have solved it. Then there is semantics metadata, which is coming from all these systems. And then there is an angle of personalization, right? So if you actually, if you looked at how we actually designed data catalogs was, we actually turned them into a passive human-centric behavior. For example, data stewards and governors would go into the portal and qualify the assets, mark the assets, and say that they are trustworthy. But then what happens is that doesn't work in this new world, right? Because in the new world, the schemas will evolve, the schemas will change, the semantics will evolve, and you will always hit this context ceiling if you are actually doing human-centric approach. So what we have done is, you take all these technical metadata, business semantics, and then personalization, and what do you know from the usage logs, how are the queries running in the system, then you actually gather it and make it into context. So what do we have done? The context ceiling gap comes in where previous catalogs are designed for humans, so they're not going to scale. There is also going to be a lot of hallucinations by the agents because your context is not really getting updated in real time, and it is actually not fresh. Then your agents will hallucinate. And then obviously, if you don't have context, your agents are not going to, do well, right? So what we have done is basically all the technologies that we are seeing are coming and they're being bolted on. What we mean by that is whenever you see this, we actually see that, when you are building an agent, you are actually retrofitting into an older technology. What we have done is we took a fresh approach to how we deal with catalogs, and we said the passive governance catalogs are not going to work in this new world. We evolved our knowledge catalog, which was formerly known as Dataplex, into an active knowledge catalog. What do we mean by that? What does active mean, right? And I think Lou is going to come in and she's going to share all the things that we have done. It's an always-on context where we can actually harvest all the context and make sure that it's always refreshed and it's always available and up to date to the systems. It's ready for consumption. And I'll talk about the scale in a second. So I think the passive governance catalog, which was human-centric, has evolved to an active knowledge catalog, which is actually agent-centric, and which has to also meet the agent scale, right? So the way we sit is, we actually, I'm happy to announce that, most of the systems, we were very BigQuery-centric catalog before, so all the BigQuery stuff was there, but we have extended the catalog to actually bring in, metadata from, your operating platforms or SaaS applications, from operational databases, unstructured GCS buckets, so on and so forth. We also have worked very closely with some of our partners over here, because we know that the enterprises have not just one catalog, multiple catalogs, whether it is Atlan, Colibra, Ab initio, Anomalo, Data Hub. We have integrations built into that so that if there is metadata sitting in there, we can actually take that metadata, put it into the knowledge catalog, and provide you a context. And what you can do with this context is, the way we envision is every single agent that we are building within Google Data Cloud first goes to the knowledge catalog for the context. And once it gets the context map, then it goes and does the work. Whether you're doing talk to your data, conversational analytics, or you're actually doing more complex agentic processes and workflows, you should be able to go to the knowledge catalog and then get the context. Now, that also includes, we have integrated with Gemini Enterprise. The deep research agent also is integrated with the knowledge catalog. So one of the key things that we are doing is, as Google, we are actually taking our knowledge catalog and we are actually using it with our own agents. So we have actually, there are 3 foundational pillars for knowledge catalog, right? The most important thing is, first is aggregation of the context. Aggregation of context is to be able to go and get the metadata from all these systems, put it in one place, and this is context from, this is metadata and context from structured data, unstructured data, other catalogs, multimodal data, and we are also looking at, adding, semantics into it. We can ingest semantic models. We can infer semantics. That is the first thing, aggregation and storing everything in one place, which makes it very efficient so that, you have one place where you have context for your entire enterprise data real estate. The second is enrichment. Now, enrichment can happen in multiple different ways. Enrichment is, one is through human in the loop. You actually add glossaries. You actually say, this is my metric, this is my measure. The other is importing semantics from other systems, but we also use our models to enrich this context. So we use Gemini, we use smart storage, GCS as smart storage, and it can do classification of your unstructured data. We actually bring in all of that stuff, and we constantly are enriching. This is not a one static step that you say, I enrich and I leave it alone. We have to do it in the background constantly. And finally, context retrieval. This is where the Google magic comes into play. And I think, Lou is going to talk about it a little bit more. What happens with when you have agents is, humans, if you go and take any enterprise, you might have 100 data stewards is a lot, right? But when you talk about agents, the future is agents will come and go. There'll be thousands and thousands of agents that can be built on the fly to do a certain job, and then they'll disappear. That means the scale at which you have to retrieve the context is also going to be huge. And what we have done is, obviously Google is a search company. We have taken the same magic that we are doing for Google search, and we have incorporated into our semantic search within the knowledge catalog, which means that it doesn't matter how many agents you have, right? You can actually build millions of agents, and the latency is guaranteed, the SLAs are guaranteed, they are getting the up-to-date context in time to be able to do their job effectively. So I think, again, the 3 foundational pillars is aggregation, enrichment, and search. So the most important thing is, in the agentic data cloud, knowledge catalog is a horizontal. This is something that is powering all of our analytical systems, whether it is Lakehouse, BigQuery. It's powering our databases, all the agents that are being built on the operational databases. It's powering our business intelligence layer. And I think what we have taken is, we have actually made sure that your context is ready for agentic consumption. With that, I'm going to hand over to Lou, who heads the knowledge catalog, and she's going to talk about detailed features, all the stuff that we have done. Lastly, I just want to again reiterate and say thanks to a lot of people in this room. You had a say and you had actually helped our direction where we are today. So with that, over to you, Lou.
Sounds good. Hi, everyone. My name is Lu Yan. It's my pleasure today to be bringing to you our exciting range of new launches around our new knowledge catalog. So as you know, our goal is to be able to provide this pervasive, intelligent, and self-evolving context layer across your entire distributed data landscape. Now, in order to do this, we're launching a wide range of new product capabilities along 3 key product pillars, including context aggregation, enrichment, and search retrieval. So first and foremost, context aggregation. This is where we're automatically ingesting metadata across GCP and third-party data sources, making sure that it covers your entire enterprise data landscape. Second of all, it's enrichment. We aim to help you transform your raw metadata into a well-curated and interconnected context layer spanning across both structured and unstructured data. The knowledge catalog can aggregate business context as well as trust signals, and making sure that it is also complete with human in-the-loop review capabilities. Last but not least, it's search. Here we introduce a variety of mechanisms for the retrieval of context, including semantic search and a corresponding context API, as well as metadata change feed for continuous real-time updates. We also offer logical organizations, including data products and domains, which are essential for targeted search and context consumption. So all of this is building towards providing this trusted enterprise context layer where your agents can now produce insights and take actions with the best understanding of your latest enterprise knowledge. So without further ado, let's get started from the first pillar, which is context aggregation. So as you know, one of the unique values of the knowledge catalog is the ability to automatically aggregate metadata from various GCP sources in near real time. So this provides out-of-the-box discoverability of your data assets across the entire organization, as you can see here in this diagram. So this year, in addition to the existing integrations, we're super excited to extend our first-party coverage to include assets also from Looker Core, from the GCP Lakehouse Iceberg REST catalog, from AlloyDB, from Firestore, as well as from DataStream. And overall, our goal is to ensure end-to-end coverage to help make sure that you can automatically establish this essential metadata context foundation. It is very important for us to make sure that we support an open data ecosystem without vendor lock-in. So that's why we're super excited to announce the GA of Lakehouse Iceberg REST catalog integration. So this would allow you to enjoy all the benefits from the knowledge catalog out of the box, making sure they work directly on top of your Lakehouse Iceberg tables, including features like semantic search, GenAI context enrichment, lineage, data quality, and so on. We also understand that your enterprise data landscape could very well extend beyond the GCP ecosystem. So in addition to providing an open API, we're also actively working on expanding the range of out-of-the-box connectors that we support in order to enable the no-code aggregation of third-party metadata context within the knowledge catalog. So for that, we're launching a range of built-in connectors, starting from the relational databases, as you can see here, with much more to come. We're also actively collaborating with our ecosystem partners for context interoperability. So here we're super excited to announce our partnerships with partners including Atlan, Calibra, SAP, Anomalo, DataHub, and Ab Initio, to share metadata with each other in a bidirectional way in order to provide this truly connected context layer for all of your different enterprise data use cases. Now, in addition to cataloging of metadata itself, lineage is a critical component for connecting the dots and for providing this essential traceability. So this year, we're super excited to announce our expanded lineage coverage, including the GA of Open Lakehouse Iceberg lineage, the GA for BigQuery column level lineage, the preview for Looker core lineage, and the upcoming column level lineage for managed Apache Spark. In addition, we're offering built-in agentic experiences for you to be able to interact with the lineage graph in an interactive way and to help you better understand data dependencies for grounding and for context management. So that concludes our first pillar, which is metadata aggregation. Now, moving on to the second pillar, which is context enrichment. Now, the critical step here is really to transform all of the raw metadata that is aggregated into a curated and well-connected context layer, which captures relationships and business knowledge. So that way, the agents can directly reason with this context. And this leads us to the whole features around context enrichment, which first and foremost, we're super excited to bring to you the insights capability on BigQuery and the Open Lakehouse. So this includes the ability to be able to generate intuitive natural language descriptions, as well as the upcoming ability to recommend business glossary terms, helping agents to truly understand the meaning of your data. We also offer relationship inference, where we mine query logs and also apply Gemini to uncover hidden relationships between the different data elements so that we can help agents derive meaningful impacts by joining different data sources. Finally, we also provide proactive recommendations for natural language questions and its corresponding validated SQL queries. They will serve as off-the-shelf examples for data exploration so that the agents can directly leverage. With all of this enriched metadata context in place, your agents can now produce much more accurate and grounded responses instead of having to guess at runtime. Now, we have spoken a lot about unstructured data, yet we all know that unstructured data is really this super valuable, massive, yet largely untapped source of enterprise knowledge. So this is why we're super excited to extend our insights capability to also cover unstructured data, starting from the Google Cloud Storage, GCS. So here we can help you automatically discover collections of unstructured data from GCS and then generate collection-level content summaries in natural language. We can automatically extract entities and relationships to facilitate complex reasoning. We also provide the automation to generate further data extraction pipelines. Looking ahead, we're collaborating very closely with our GCS colleagues to integrate with a new object context feature coming out of GCS to help you uncover even deeper insights from this unstructured data. Ultimately, what we're working towards here is a connected context layer that spans across all the different types of data and transform them into agent-accessible knowledge. So that way, your agents can directly answer questions and take actions on your behalf in much more complex, multimodal situations. Now, it is very important that the metadata context that we collect and generate in the knowledge graph are not just automated, but can also be reviewed by your domain experts as needed in order to ensure that the context is certified, accurate, and trustworthy. So this is why we're very excited to introduce metadata workflows for data stewards to be able to review and to approve metadata changes before they're made available to agents and data consumers. Then we also have Business Glossary, which, as you know, is this foundational capability which would allow you to codify business definitions and its data mapping. So this allows both agents and human users to be able to find the right data for accurate and grounded analysis. This year, we're very excited to bring to you not only the GA of the business glossary, but also many enhancements, including the at-scale assignment, bulk import, bulk export, to help you really get a jump start building out this essential element of your enterprise context. Last but not least, within this pillar, we wanted to help you track the important quality signals for your assets. As you know, we offer automated data quality checks, and now it also offers support for reusable rules, which allows you to define the validation logic just once, including as part of the business glossary terms, and then be able to apply it at scale across your different data assets. At the same time, we also offer anomaly detection using Google's latest machine learning technologies, helping you catch data outliers proactively. Now, all of this form the very important trust signals, which are essential elements of your enterprise metadata context to help you decide if a given data asset can be used for analysis in the first place, or if any remediation actions need to be taken. That was an overview of the metadata enrichment pillar. Now let's move on to the third key pillar, which is search retrieval. So this is where we support agents and users to easily retrieve and consume context from the knowledge catalog in a seamless way. So here, we're super excited to announce the GA of the knowledge catalog semantic search, which supports discovery of your org-wide assets in natural language. It uses a hybrid search stack based on decades of Google's native innovation in search. In this agentic era, we realized that search has evolved to be in the query path itself. So correspondingly, we have invested significant effort to ensure that the knowledge catalog search is truly low latency, high scalability, and has strong relevancy to support runtime agentic use cases. Moreover, our search is secure and governed, respecting echoes that are set at the data source to ensure that agents can only access what they have been explicitly authorized to see. Now, on top of semantic search, we also offer a discovery agent, which leverages Gemini's reasoning capabilities to break down complex search intent into component parts. And it also supports multi-turn conversations for much more targeted search retrieval. Now, related to search, we're super excited to launch a dedicated brand new context API for agents. For any discovered assets from the knowledge catalog, it will retrieve its complete technical, operational, and business context in an agent-friendly format. You can also make use of semantic search and the context API through many different interfaces, as you can see here. Semantic search has already been integrated into many of GCP's first-party agents, including the BigQuery conversational analytics agent, as well as the deep research agent provided by Gemini Enterprise. We have also launched a whole set of MCP tools and skills in order to plug in into your own workflows. We have embedded knowledge catalog functionalities also as part of the Google Cloud Data Agent Kit so that you can leverage the knowledge catalog context no matter where your development work happens. At the same time, we're also launching a business user interface, which is an open source implementation that provides a much simpler, streamlined user interface based on popular demand we have been hearing from you, our customers, to discover data and to even request access in a self-serve way. Now, in addition to search and the context retrieval API, we're launching the GA of metadata change feed. This would allow agents and other workloads to subscribe to streams of metadata changes coming from the knowledge catalog for all different types of context automation. Now, a key element of context is the curation of assets into prepackaged data products for specific use cases. For that, we're very excited to be launching the GA of data product this quarter. It allows you to not only package different assets into product, but also generate rich context on top of it, providing this complete unit of data and context bundled together, which can immediately activate agentic use cases. And then above data product, domains enable at-scale organization of assets according to a logical structure. So a domain or subdomain, as you can imagine, would contain multiple different data products, and this greatly facilitates resource discoverability for agents and human users, and would also enable consistent at-scale context management. In the interest of time, this is a high-level overview of all the highlights of our new knowledge catalog launches this year. And overall, with this wide range of new innovations, we strongly look forward to partnering with you and making your agentic journey successful. Next, I will hand it over to our guest speakers from Bloomberg, Katherine and Hann, to share with you their exciting use cases of building agents with the knowledge catalog. Welcome, Katherine.
Thank you, Google, and thanks everyone for coming. I'm Katherine, and today Hann and I are going to be talking about how we built the catalog for our AI agents. Okay, so before we can jump into context enhancement for our agents, we first want to touch on who we are, the data we work with, and the systems that we've built for data governance. You might know the name Bloomberg for its financial data or the Bloomberg Terminal, but Bloomberg Media is the consumer-facing media organization of Bloomberg LP. Essentially, we're the product and commercial engine of Bloomberg.com and app, subscriptions, audio, video, and events. And within Bloomberg Media Engineering, the team that Hann and I are on has evolved its focus from that of a traditional data engineering team, so that's like writing data ETLs, into now expanding data governance for agentic data access. Now that you know who we are, let's consider the data that our business needs. From first party to third party, everything from article metadata to web analytics, that's stored in our data lake. Now imagine you're an AI agent trying to answer the question, what's our monthly net revenue? Your first concerns might be, which of the many tables relate to revenue? What exactly does net revenue mean anyway? And that's just where the problem begins. So these are the features of the knowledge catalog that we use, but today we're just going to focus on the ones that are most relevant for agents retrieving context, and that's custom aspect types and business glossary. Our data governance lifecycle is composed of 3 distinct components. We have the foundational layer, that's the data contracts. And this is a system that our team has built to allow other teams to maintain the schemas and the metadata for the tables that they own. The second layer is Google's knowledge catalog, which is where we house our metadata from contracts, as well as the glossary terms directly from data owners. Agents access this metadata and business context via catalog search. The top layer here is BigQuery, where we host our data lake. Agents and analysts alike run SQL here to access our data. So using this layered system that we've built, what context can we give an agent? The primary context is the schema level context. That's data contracts. And a data contract is essentially a Git version controlled schema augmented with metadata. And that auto-populates our BigQuery schemas and our knowledge catalog data. But an organization is more than just the data ingested from various sources, right? So much essential knowledge lives in the brains of those who use it daily to answer business questions. And glossaries give us a modern way to capture and make accessible this business context, which becomes just as useful for humans learning as it is for AI agents. Even with all of this previous context, we're still missing something critical. Let's consider one type of so far uncaptured metadata. How should a table or columns within that table be used? We created a custom aspect type in the knowledge catalog to store these table best practices, and an aspect is essentially just a flexible annotation that can be attached to entities like BigQuery tables that then become searchable in the knowledge catalog. We call these aspects our table usage notes, and we will revisit them very soon. Here's a high-level view of our data access agent, which is a multi-agent system that we've built with Google ADK to answer a user's natural language question with SQL and data from our data lake. It does that by retrieving context from the catalog using MCP tools, and then generates and validates that SQL using BigQuery tools. So it kind of seems like the natural language to data problem is solved, right? But no. There's a significant hidden issue that emerges once you move beyond these small, clean POC data sets into any real-world data environment. To illustrate this issue, we're going to walk you through what we call the $42 problem. And as a reminder for those of us who napped through Intro to Accounting, net revenue is calculated by taking what we earned and subtracting out our transactional expenses. And a quick disclaimer, while the issue itself is very real, the data and the business rules used here are fictional. So in this scenario, I'm going to play a senior data analyst, and Hwa's going to play the junior data analyst. Oh, hey, Hwa.
Oh, hey, Katherine.
Management just asked for a report on our monthly net revenue, and they need it today. And by today, I actually mean before they redefine what revenue means. And listen, I would do it myself, but I'm buried under 10 other quick asks from management. And I know you've just started working here, but your SQL skills are solid, and I'll give you access to the knowledge catalog. Do you think you could handle this one?
Yeah, sure, no problem. Let me try this. Okay, I'm opening my laptop. Let me first search in the knowledge catalog to see what product table do we have. It seems like we have over 200 tables, very comforting. So let me see whether we have any table that stores revenue data. So searching with the keyword revenue. It seems like we don't have revenue table. So if revenue isn't stored directly, can it be derived? So maybe we have like a billing table. Let me search with the keywords billing. Oh, I found a billing invoices table. That must be the one. Oh, but let me think. Revenue isn't just about what we earned, it's also what we lose. So maybe there is a refund table. Let me search with the keyword refund, no table. How about the different keyword? Disputes. Oh, I found a payment dispute table. That must be the one. So I think I found all the tables I need. Now let me try to write the SQL. Okay, done. Zero syntax error. Honestly, I'm just too good at this. AI has no chance of taking my job. Oh, Katherine, you can take a look?
Oh, yeah. Okay. Let's see. Oh, you showed such promise. Right tables, right logic, but yeah, this number is totally wrong. You need to add $42 to our revenue lost for each transaction. Right now, you're just using amount.
Oh, wait, isn't what I wrote the industry standard way of calculating net revenue?
Yeah, everywhere else, but here our payments vendor charges a $42 fee for each dispute filed by a customer.
I see, but like if $42 needs to be included, why didn't our data engineering team bake that in as part of the data pipeline?
Well, it's vendor and contract specific, so it doesn't really make sense to hard code it into a data pipeline.
Okay, understood. But at least, is this knowledge documented anywhere?
Yeah, of course. There's a Confluence page from like 2017. But the author, I think, actually left the company.
Oh, I see.
But that's the point. Hwa did everything right and still got it wrong, because the hard part isn't the SQL. It's the missing context, or you might know it as institutional knowledge. Now imagine an AI agent. Same data, same logic, same mistake. What we have here isn't a data problem, it's a $42 knowledge problem.
Thank you, Katherine. Great job. I think I'll take over from here. So actually, from the past experiments, we found out that data access agent did hit a key limitation due to the exact same reason. So this isn't very surprising, because this institutional knowledge is very critical, but currently it lives in people's heads, scattered across docs and files with no real inventory of records. So now the challenge is not just how can we improve the agent, but how can we systematically capture and organize this kind of missing institutional knowledge, and how can we store them in knowledge catalog so that both human and data access agent can use it and benefit from it. So to systematically capture this missing institutional knowledge, we introduced knowledge gap agent. We call it KGA. It is a separate agent. The role is very simple. It learns from mistakes. Specifically, it looks at where the data access agent fails, and it reasons over why. And then, after this analysis, it would automatically update knowledge catalog based on it. So next, let's take a look at this 5-step KGA workflow. First step is to identify input. The KGA agent looks at the user conversation history with the data access agent and try to identify 3 key components as its input. The first component is the natural language question. For example, what is the net revenue? So the second component is the current data access agent generated SQL. And the third component is the user feedback. For example, a user can say, a $42 dispute cost needs to be added. And then on step 2, the KGA searches in the knowledge catalog to try to fetch the relevant question-specific data context. It can be a few business terms. It can also be some usage notes aspects attached to the table. So now, given all those information, the KGA reasons over this question. What did the access agent do versus what should it have done? And then, in step 3, prompt a structured context update. So this update can be about metrics and business definitions. It can be join rules and constraints. It can be data caveats about a specific table. And then in step 4, KGA present this data context update to human for certification. And then the last step, after the knowledge gets certified, it's automatically persisted back to knowledge catalog, forming a full loop. So instead of repeatedly making the same mistake, the system learns once and improves knowledge catalog permanently. And here is how KGA fits into the overall architecture. And this is our DA agent from earlier slides. And now this is our new KGA agent. There are 2 key things to notice about this KGA agent. First, it's a separate agent from the data access agent. The separation is very intentional because we don't want to complicate the query generation process that's happening in the data access agent. So we created a separate agent that can focus on learning and improving our data context. And the second key point about KGA agent is it actually uses some of the same underlying MCP tools as the data access agent. So it can actually see the data context world from the same eyes as the data access agent. This is very critical because only in this way, it can not only understand that the SQL is wrong, but why it is wrong, given this available data context. So now let's talk about results. During the data access agent MVP development, there were 102 usage nodes auto-generated by KGA across 20 MVP tables. Those usage nodes actually improved data access agent SQL accuracy by 63%. And it saved dozens of stakeholders' hours, which would have been spent manually deriving those knowledge gap for data access agent. So now, let's bring this to life with the demo. I'll be using the same example. What is the monthly net revenue? And from the role play, we knew the key detail here is on calculating cost dispute, it requires an additional $42 fee. First, let's take a look at the payment disputes table in knowledge catalog. If you go to the aspect section, we have a usage note aspect attached to this table. And in the note, it says on calculating cost dispute, a fixed fee of $42 must be added. Now let's ask our data access agent this question. What is our monthly net revenue? In the SQL generated, data access agent correctly added the $42 on calculating dispute cost. Now, to verify, I further asked it, why did you add this $42 fee? And it referenced back to the table usage notes attached to the payment disputes table in knowledge catalog. Now, in a hypothetical scenario, I told it, recently the fee has been increased to $88 from the previous $42. It immediately retried the SQL generation, and in the new SQL generated, it correctly used the $88 fee. But here's the issue. This $88 knowledge is trapped in this session. On user opening a new session, the system falls back to the previous $42. And here's where KGA comes in. I simply click the Update Knowledge button on the top right corner, which triggers a KGA run. Behind the scene, we've switched to talk to KGA instead of the previous data access agent. And KGA looks at the user conversation history and try to learn from it, and try to identify where in our data context we can update. Okay, the knowledge updates, let's take a look at the suggested knowledge updates. The first update is encouraging using a left join, which is the potential SQL improvements that user didn't even think of. And the second data context update is based on my feedback in this session. KGA not only identified the correct place to update among hundreds of possible places, it also correctly suggested the fee change to $88 from the previous $42. Now that the apply back to knowledge catalog is successful, let's verify. I simply refresh the knowledge catalog page for the payment disputes table. Let's go to the usage note aspect. Now the first note says to calculate the cost dispute, you need to add a $88 fixed fee. So instead of the knowledge staying trapped in conversations, it now becomes structured, shared, and reusable. And this is how we turn institutional knowledge into system knowledge automatically. So that's takeaways. First takeaway, during this session, we shared our data access agent, which consumes the custom metadata table usage node aspect from the knowledge catalog. And second, we highlighted that the missing institutional knowledge is a key challenge in AI agent development. And at last, we demoed our in-house solution, KGA, which addressed this challenge by systematically capturing and evolving knowledge from user interactions. And also during this session, Google has introduced many cool new features on Knowledge Catalog, like the metadata update workflow and the data insights enhancement. So with them, customers like us can have a way stronger data context out of the box. So we're very excited to try them out and keep improving our agent system. So this would be all the content for our presentation today. And thank you so much, everyone, for joining us.